All right, we're going to keep going. Let's do a new function, though. I'm kind of over those quadratics. Let's do a cubic. Let's look at the function f of x equals x cubed. And I would like you all to compute this area right here. The area between the graph x cubed and the x-axis. You've got all the tools you need. Check with your neighbor. Make sure you're on the right track. You'll get an answer of 4. If you get done with that, go ahead and do number 8, which is the same thing with just a little bit more to the region. Okay. All right. See how we're doing. Okay, so we ended up with the definite integral from x equals 0 to x equals 2 of x cubed dx, which gave us 1/4 x to the 4th evaluated from 0 to 2. Okay, do you need that evaluation bar?
Yes.
Yes. Okay, folks, what did I do from here to here? I took the antiderivative, so I'm done writing the antiderivative symbol. Right? All right, then this gives me 1/4 times 2 to the 4th minus 1/4 times 0 to the 4th. Could you just put a 0 there? Oh boy, you betcha, right? I'm just showing you the procedure. Okay, and we end up with 2 to the 4th is 16, divided by 4 is 4 minus 0, or 4. Okay. All right, what's going on here? Well, let's do the work. This is the antiderivative from minus 2 to 2 of x cubed dx, which is equal to 1/4 x to the 4th from negative 2 to 2, which is equal to 1/4 times 2 to the 4th minus 1/4 times negative 2 to the 4th. Which is 4 as before, but then what is this? Well, negative 2 to the 4th is 16, divided by 4 is 4. We get 4 minus 4, we get 0. Now this is not a horizontal line at the line, this is not the line y equals 0, when I'm asking what's the area underneath the curve in the x-axis. What's going on here? We found the net area. Let's be careful, net area as opposed to total. Okay, so we're not actually going to carpet this. Okay, we're looking for the quantity, and this came out to be 0. Okay. By the way, if we wanted the total area, what would the total area be? It'd be this 4 plus this 4, which is 8. Okay, but the net area here is 0. Okay, there is a little time-saving thing we can do here and say if f is odd, if f is odd, then what would be the integral from minus a to a of f of x dx? It would just be 0, because one way to look at that, and we're not going to make this statement, we're not going to prove this statement, but the antiderivative of an odd function is going to be an even function, and when you evaluate even functions at opposite domain values, you get out the same thing, so the difference will always end up being 0. Okay, if I said that too fast, just take this as a handy little theorem. Okay? So there are two things that we require. First, that the function be odd, but that's not enough. You also have to have equal yet opposite limits of integration for that to happen. Okay? So sometimes people only remember, oh, it's an odd function, the antiderivative is 0. No. Or the definite integral is 0. No. That would be opposite sides. For the one way to look at it is those rectangles are all perfectly canceling each other out.